Hello students, a very warm welcome to this Units and Diamonds lecture on by JEE English by Unacademy, which is India's leading and largest test preparation platform. And students, you are on JEE English, which is the nation's first channel where you get all your lectures from the basics until your advanced, exclusively and completely in English. So do not forget to click on that subscribe button and bell notification. And students, today we are going to explore a very interesting concept. Like dimensional analysis, we are going to explore those quantities that frequently appear in your exams, or something that we do generally miss out. Like in terms of let's say in terms of units, or in terms of the physical quantities that requires dimensional analysis. Not only that, today we are going to understand something interesting known as significant figures. So these are the today's two topics that we are going to explore. So stay tuned and make sure you're taking down the notes and also calling your friends for this lecture. Hi, CS, hi. And that being said, hi Venkatraman. And guys, who know me well and good. If not, I'm Murlidharan Gopalakrishnan. I completed my MS in Electrical Engineering from University of Colorado Boulder. I'm also an IITian who completed my BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams. And students, we have a very awesome Telegram channel where you may want to get on to, because you get all the live notifications on what is happening every day. Lectures are posting on DPPs and many other things that are happening on JEE English channel, be it on YouTube or Unacademy Learning app, or any surprises or any news. You will get the notification in time if you are on this Telegram channel. So do not forget to get onto this Telegram channel. All you need to do is download the Telegram app and then click on to this link available in the description box below. And hi Kovi Anudeep, hi. And that being said, students, today, do make sure that you get onto this, and just if you are already on Telegram, just do type in JE_English and you will find this channel. And students, that being said, if you missed the previous lecture on Unacademy Learning app, some special lectures conducted by me. So guys, last class was on electrical instrumentation in one shot. You may want to cover that as well, because it carries a lot of weightage in IIT JEE. Not only that, it's independent of any other topics. That's the speciality of current and electricity. So do attend that lecture. Also on 31st of August, we covered this topic known as color coding of resistors, which is a very important topic. Not only that, it's a very easy one. All you need to do is spend a little bit of time, and there were anywhere about 5 questions combined together in JEE Mains 2019. So do cover this class. It happened on 31st of August, and stay tuned to get many updates on these kind of things, guys. So that being said, students, if you have already downloaded Unacademy Learning app, well and good. If not, download the Unacademy Learning app if you're attending it from the web-based version, because you will get all the notifications, live notifications on the lectures happening every day. And that being said, guys, there are many such free special classes going on. So do not forget to download the Unacademy Learning app. All you need to do is type in Unacademy on your Google Play Store and App Store. And the first result is going to be Unacademy Learning app, and then you will click on this install button. Also, plus students, make sure you get the notifications on the time, so that you need to for that you need to download the Unacademy Learning app. And guys, we have an awesome complete special package for your JEE preparation, which comes with live quizzes, live test series. Not only that, you get to learn from your favorite educator, all IITians and the best educators and authors across the nation on this one platform. And it's more of a systematic preparation for your JEE. Of course, you get your lectures for free on Unacademy, which is impacting about 10 million lives a day. But guys, do remember, JEE preparation is also about your timing, and you must get accustomed to that kind of environment, and that comes on our subscription platform. And not only that, guys, you get that the real-time environment, the way you would be attending your exams on Unacademy subscription platform, and this is equipped with the state-of-the-art technology. So that being said, how do you avail this? All you need to do is click on the extension bar and click on that first icon, and you need to choose your goal as IIT JEE, and post that you'll just get on this subscription. So you need to get the subscription post choosing your goals. Be sure to choose your goal, guys, because it's very important that you choose the right kind of goal for your like test preparation. And it's going to be a very systematic program. You're going to have weekly quizzes, and also like many more things. There are many more things. There are many advantages of being on subscription platform. And that being said, guys, right now the prices are low, so avail it before 10th of September. 24-month packages anywhere around 1,500 at the moment, and you can apply Murli Live coupon to get a 10% instant discount on this purchase. And especially 9th, 10th, and 11th class students, start early, get the subscription right now because it is like super low. And if you're going to go for a 12-month subscription, that would be generally be applicable for long term or dropout students. It's going to cost you anywhere around 2,500. Yes, Venkatramana. Yes. Good evening, Kovi Anidhi. Good evening, everyone. And guys, long-term and dropout, don't worry. We have anywhere around 80 plus courseworks. I mean, like programs, not courseworks, but programs dedicated for your JEE preparation going on this platform. And if you think 2,500, near about 2,500 is expensive, do apply this Murli Live coupon to get a 10% additional discount on your purchase. So do not forget to apply the coupon, and post that you'll get an awesome discount. Not only that, guys, hurry up, avail it right now because the prices are low. Right now the prices are anywhere super low compared to what it would be after 10th of September. After 10th of September, like the prices are going to be hiked, especially 11th class students. Don't delay the process. And also start early. If you're already on subscription platform, do give your test series, make sure you're timing everything, and make sure you're taking advantage of the personalized insights that you get over Unacademy subscription platform. And students, that being said, so what is the right now, the cost for your 2-year subscription? It's anywhere around 32,400. And after you apply your Murli Live coupon. But after 10th of September, it's going to be anywhere around 15,400 even after applying Murli Live coupon. That is after your 10% discount. So it's going to be more expensive than what it is, anywhere by by 18,000. So make sure you avail it early, students, so that you don't miss out this opportunity. Uh, Basic mathematics, Anudeep will take it up. We'll take it up. So today's topic is actually very interesting, guys. So it's very practical. So it's like what you would be dealing in your labs and etc. So this is a famous quote by a famous scientist, Max Planck. He said that an experiment is a question which science poses to nature, and a measurement is the recording of the nature's answer. So we are basically going to deal with something known as, I hope everyone has gone through the first lecture. If not, we are going to revise the concepts. So don't worry, we're going to revise the concept very shortly, and we'll do many, important dimensional analysis in this lecture, which you may require for your JEE Mains preparation. So do not forget to click on that like button and share button. Call your friends on board because today's lecture is going to be super interesting, and we are going to test those questions which science has posed to the nature. So let's get into the lecture. Let's not wait anymore. And as you know, there are two type of quantities. One is non-physical quantity, and the other one is physical quantity. What do I mean by non-physical quantities? Any emotion, sadness, happiness, or like excitement, these cannot be measured with a physical scale. Whereas physical quantities, for an example, mass, time, energy, can be measured using a physical scale and can be compared, whereas non-physical quantities cannot be compared. So you can measure a physical quantity and you can compare a physical quantity, whereas a non-physical quantity, you cannot measure them, and it's a very like a relative thing. Someone you might think, for an example, easy and hard, that's also a non-physical quantity. So that being said, guys, among those physical quantities which is relevant to our discussion, there are two kinds of physical quantities. One is fundamental. For an example, amperes. Do remember, amperes is the fundamental physical quantity, whereas your coulombs is a derived physical quantity. So what is a derived physical quantity and what is a fundamental physical quantity? So when we are talking about fundamental physical quantities, they are sufficient to communicate any property or measurement, or they're good enough to even sometimes to compare to physical quantities. So fundamental physical quantities are the base. So this is where like these anywhere around this 7 quantities are good enough to define any given quantity in this world. I mean, like any physical quantity in this world. And the basic 7 physical quantities are luminous intensity, electrical current, length, and time, mass, temperature, and amount of substance. Okay, so these are going to be your like the 7 fundamental quantities using which you can define any derived quantity. So you got an idea of what is a derived quantity. For an example, Newton is a derived quantity, whereas luminous intensity is a fundamental quantity to measure intensity of light. And similarly, electric current is a fundamental quantity. Okay, and length, time, mass, do not forget amount of substance. So yes, let's first understand how do we measure this, and is there a standard system to do that? Yes, of course. So there is something known as SI unit, System International, or International System of Units. It's the standard language. So what are we doing through units? We are communicating the measurements. We are communicating the measurements. We have a standardized method, and this standardized method is called as SI system. And SI system lets you efficiently communicate things and also compare any physical quantity. And you can measure in SI units and communicate in SI units, and people across the globe will understand. Whereas FPS, CGS, MKS is going to change. I mean, like, it's not going to change from place to place, but the way it is being communicated in generic life or general life is different for different places, and also for different kind of materials and different kind of things that you purchase from your market. But a standard thing that we use in our in science and physics, when we are talking about like all this lab measurements, is generally SI units. And so this 7 fundamental physical quantities have the SI units, which is very necessary to understand. And like these yes, Surya, you can join the Unacademy educator group. Yes, of course. And that being said, guys, so I know that you all are aware of the basic fundamental physical quantities. Like for an example, m is nothing but meters, like an SI unit of length. A is nothing but amperes, like an SI unit of the fundamental quantity current. And Cadilla is nothing but like an SI unit of luminous intensity, and mole is the SI unit of amount of substance. And what about S? S is nothing but seconds, and kg, and K goes with Kelvin. So you need to remember these, like SI units and these 7 physical quantities. And based on this, using your formulas that you remember, you will be doing your dimensional analysis. All right, students, that's all. That is all your, your dimensional analysis is all about. You need to remember the SI units, you need to remember the fundamental quantities, and you need to remember few formulas. And that being said, what are all derived units? Anything other than fundamental, like quantities are, sorry, what are all derived quantities? Anything other than fundamental quantities are derived quantities. And it is called derived quantities because you can always express these derived quantities in terms of, like the fundamental quantities: mass, length, T is time, K is temperature, I is your current. So here we have all the derived quantities. So you'll be expressing these derived quantities like Tesla, units of magnetic field, Pascal, units of your pressure, Coulomb, which is a derived quantity which you can express it in terms of amperes and time. Okay, so I and T is what you will use to express coulombs, and there is many such farads, like for capacitance, ohms, volts, and Newton, the most famous one that you guys are really very aware of, especially if you're in first year, you must have heard a lot of Newtons and Newtons and Newtons. And but do remember, these are like the dimensional expressions. This is how you are going to express in your dimensional analysis. And guys, what is M? M represents mass, L represents length, T represents time, K represents temperature, Kelvin, I represents current, J represents luminous intensity, N represents your amount of substance whose SI unit is mole. Okay. So these are the 7 things to express your any derived quantities. So any quantities across the world can be expressed using this fundamental quantity. And that being said, there are also something known as supplementary physical quantities. These are generally mathematical quantities. The thing about supplementary physical quantities is that they are neither base quantities nor they are derived quantities. So they are not derived from anything, and neither they are like, they are the base units to express anything. And there are two kinds of them. One is going to be a plane angle, and the other one is going to be a solid angle. And the SI unit of plane angle is radians, and the solid angle is terdian. And what about the formulae? The formula is going to be A by R square for solid angle, and for, you know how to do it for, general plane angle. You remember circles formula, you remember how to derive the arc and etc. So you know what you need to do is basically length of arc by radius. Okay, so you can analyze them and you'll understand that neither Sturdian or radians, they don't have any dimensions. They are dimensionless. So supplementary quantities are dimensionless. Uh, yes, sir. So yes, one of the questions is like, what is J and N? N is very okay. All right. I'll do a thing. Let's get over here and understand one by one. So N is the dimensional expression for your amount of substance. And what is the SI unit, guys? Mole. And what about J? Luminous intensity. That's actually a very good question. So that's going to be luminous intensity, and what is its SI unit? Cadilla. Okay. And what about, yeah, Cadilla? That's correct. And I, it's current. And what about K? K, it's temperature. And what about T? T, MLT is quite popular amongst you guys. So T is basically time, and L is length. All right, that is it. So yes, yeah. So SI unit of current is ampere. Do remember, students, there lies a lot of confusion in most of us that coulombs is like fundamental quantity, but coulombs is not the fundamental quantity, whereas amperes, while we are communicating, is the fundamental quantity. All right, and L is length, and what about M? M, it's mass. All right, that's it. So using these 7 things, you can express any given quantity. So these are some examples. You can go through them again. But that being said, yeah, it's coulombs per second. Yes, that's correct, Kobe. Yes. So yes, you can express force. You can express, once you know force. Like, let's say I've been given the dimensional formulae of force, and now how do you calculate the work done or energy? F into D. So it basically increase one power on length. It was L to the power 1. It's going to be L to the power 2. And similarly, pressure is force by area. So you would divide it by A, which is going to be L square, and once you're going to divide it by L square, you're going to subtract -2, and these on the top are representing how many dimensions of that fundamental quantities are present. Okay, so that being said, now let's understand this point. So yes, for an example, in this case, the force is m to the power 1, L to the power 1, T to the power -2, K to the power 0. Okay, that means there is no temperature involved in finding force. Okay, and it is going to vary by the order. So what is n? N is nothing but order of that fundamental quantity. Order of that fundamental quantity. Okay, so we covered that these entire thing, each one of them in depth in earlier lecture. You can later on go and explore them, but today we are going to cover a very important concept. And yes, So that means it varies with by the order -2 when it comes to time. When it comes to length, it varies by 1, and when it comes to mass, it varies by 1. Okay, so if you increase the mass, you come to know the impact. If you are going to let's say give that acceleration or give that velocity or move that object with some time, then you will come to know the impact. So basically this order is directly and indirectly telling you how these things are happening. And the base, which is nothing but the base we are using here, M, L, T, K, I, J, N, are going to tell you the fundamental quantities involved in deriving this derived quantity. All right. So yes, that being said, you can explore later. Let's get into some challenge problems, students. This is going to be very interesting. This is a very common one. So what do you think is the dimensional formula of gravitational constant? Get started on this, student. So the rule of thumb for doing any dimensional analysis is really simple. All you need to do is you need to actually remember any formula related to them. Try to remember the easiest formula so that you're able to do it quickly. Okay. So find the dimensional formula of gravitational constant G. Any guesses, students? Are you sure, Venkatramana? Is it dimensionless? Is gravitational constant dimensionless? What do you think? So let's try it out and let's see. Uh, Amazing, guys. Amazing, amazing, amazing. Really, 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 really awesome, Kovi. Yes. Kovi Anudip, that's correct. That's absolutely correct. What you said is absolutely correct. So you have to simply remember F is equal to G into M by R square. That's correct. Yes, what you said is correct. So what is the let's generally I like to go this way. You can do it anyway as you like. I generally like to express things in terms of SI units, which we are more used to. And yeah, let's see what is it correct or is it wrong. Let's check it out. But anyway, you need to understand. So L is not -1. L is to the power 3. No, M is not -1. Because M is -1. Let's check it out. Yes, it should be M -1. That's correct. Yes, yes, yes. There should be -1. There should be -1. Then answer would be T. That's correct. Yes. So it's going to be kg meter per second. That's amazing, Kovi. That's amazing. That's amazing means amazing. Really amazing. So and let's keep just G as G, and this is kg square. So this is a very convenient way of doing it, and this is meter square. Okay, just cancel this out and take it over here. So what are we getting? So you're getting that the units of G should be something like, so the idea is to remember the easiest, like formula that, in this case, you have no exception. This is like something you have to remember, that gravitational law, and this would become super easy. Yes, Kovi Anudip, that you're absolutely correct. Yes. So write it in terms of MLT, m to the power -1, L to the power 3, and T to the power -2. So gravitational constant, so if I'm talking about constant, they are not dimensionless. There are some quantities that are dimensionless, but gravitational constant is not dimensional. So very interesting. Many times in your JEE exams, it's all about gravitational constant. Okay. So there are a lot of questions in your JEE Mains and JEE Advanced exam. If you explore the past year papers, you'll see that it's pretty much around gravitational constant. We'll take up that kind of model problems as well. But today we are going to explore something really, really interesting. But really amazing, Kovi Anudip. That was pretty good. You did catch it. No, 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 Venkatramana. No, constants actually do have dimensions. Let's see, is there any constants that do not have dimensions? Once we get in the lecture, let's not break the suspense. And yes, it should be m to the power -1, guys. So correct this. So yes, it should be m to the power -1. That's absolutely correct. So you all you need to do is remember F is equal to gm by r square. You know the force, how to what is the SI units of force. From there you can derive. So now get on to this, guys. Now get on to this. Find the dimensional formulae of electric field. Very easy, guys. Very easy. So what about this, Venkatramana? Why don't you get started on this? This is going to be super easy, and let's try it out. If this is also a cakewalk. You saw that gravitational constant is not really tough. I told you dimensional analysis is going to be super easy. Today we'll see even most of the quantities, be it magnetic field, electric field, all these quantities can be derived quite easily. That is our objective going to be today. So let's get started on the electric field, students. So what do you think? So what should be the answer? Think again. D cannot be the answer, right? Why D cannot be the answer? Students, any guesses? What is the simplest way to do this? So why don't you get started on the formulae that is related to this dimensional analysis? Okay, I'll get started on this, but meanwhile, you also try it out. So the formula, the easiest formula to derive electric field would be what? F is equal to QE. That is all you need to do. Kovianadi, try it out again. F is equal to QE. What this should be? Students, note it down. At least note down the methods, note down the formulas. By the end of the session, you should be thorough with the formulas. Meters per second. What is Q? Q, can I say this is nothing but ampere into second? So yes, just a moment. I'll show you the options again. You can check it out. So these are the options, and D very well is not the answer. And of course, there is no two charges in electric field, and this is also not. Yes, try it out, students. It's a very easy one, isn't it? Just like how we did it. So let me get started on this. Try it out, Kovi. You should not just guess it right away like that. Earlier, your answer was amazing. Now try it out. Try it out. So electric field to denote to an. If you have even done it, like twice or even twice, unlike rest of the topics, everyone can do this and you can score in this. Okay, everyone can do this kind of things. We'll take up the problems and we'll understand. All you need to check is the dimensional consistency in your dimensional analysis based problems. Okay, electric field is the SI unit is something like this. So let's try to express this. So this dimensional formula, what it is going to be? MLT m to the power 1. What is L to the power? L to the power also 1. T to the power minus 3 and I to the power minus 1. All right, that is it. Okay, so that is it, students. So it should be option C. All right. So remember how to do this. The simplest way is write down F is equal to QE. So I tend to use force as the standard thing to derive any given like SI unit or physical quantities dimension. So that is going to be like, according to me, it's the easiest one to do it that way. If you notice, through this entire session, I'll be just making use of only force, and the rest would be like some other quantity, like charge. In this case, in the earlier case, it was nothing; it was just mass and distance. So that way, it's going to be very easy. A is amperes, isn't it? So yes, students, A is amperes, and Yeah, don't worry, your option is correct. Yes. So A is amperes, and you know what is S? S is seconds. Okay. So any other queries, guys? All right. So when you're writing in dimensional analysis, A is going to be written as I. So you'll have I to the power minus 1. Okay. I think Kobe, you missed out L to the power 0. It cannot be, right? All right. So let's move on. So this is the dimensional formulae of your electric field. Now let's do something interesting. So any guesses, students? What should be the dimensional formulae of electrical permittivity or electric permittivity? How would you do this question? See, to be honest, no, none of us do remember, like anything other than, we don't really remember dimensional formulae. But this is a very important thing when you're going to get into experiments, or let's say you're proposing new theory, new formulas, new expressions. You need this dimensional analysis too. You need to do the dimensional analysis and you need to check the consistency. That's the key. Okay, if your dimensional analysis is not valid, then your experiment, your new research is not valid. Okay, so this is something very interesting. See, Ovi, the entire point is I'll give you the formula, but the thing is you should do it without formula, students. Okay, you should do it without the formulas, but at least by the end of the sessions, today we are going to discuss anywhere around, 9 such, like physical quantities, 9 such units, which may come in your exam or which is very much, not much discussed, but you need to be aware of them. So by the end of the time, you should be aware of what kind of formulas you should be using while deriving them. Yashwant, a good question. So one of the students had asked, Yashwant has asked, can we by heart the dimensional formula? Very tough. Actually tough. According to me, it's tough. It depends on person to person. Maybe there are a few people, some of you guys are smart. Maybe you can remember them. I'm not that smart, guys. I can't remember this dimensional formulas. All I can remember is, force is equal to mass into acceleration. This comes from the laws. Okay, so let's get started on this. Let's first of all understand what is permittivity and how to derive it. So how do you express force? So this is related to your Coulomb's law, isn't it? 1 by 4 pi epsilon naught. Epsilon naught will have same dimensions. Okay, epsilon and epsilon naught will have same dimensions. Relative permittivity does not have any dimension. Okay, if you're totally new to this, forget it. Remember this. This is something. This is Coulomb's law, guys. It says that force is equal to 1 by 4 pi epsilon naught, or epsilon actually epsilon q1 q2 by r square. You know what is r? Just like your gravitational thing that you did. Okay. So yes, Yashwant, this will be the standardized method, at least for me. I don't remember, all this dimensional formulas. So this is the way I go about. So yes, so I can write down. Forget 4 pi. This is dimensionless. Pi is dimensionless. This thing. Dimensionless, so L should not be there. So yes, we get started on this. You got your formulae, so I guess you should be giving out the answer. Yes, that's correct. Yeah. Amazing, guys. Amazing, amazing, amazing. So what is this? This is Coulomb's law, students. Do remember this. This is Coulomb's law. You should be by hearting this thing. Okay. Not only that, once we get into electrostatics, you need to remember this thing. This is a law. Like just like F is equal to GMM by R square. This is a law. Okay. So what is epsilon? Epsilon is nothing but something 1 by 4 q1 q2 by r square. Yes, students, all of you got it correct. Yes, that's true. Anyway, let's do this. Maybe there are like other students watching this, and also some of them are just new to this concept, just started with IIT JEE preparation. So What is force? Mass into acceleration. kg meters per second square. And q1 ampere. q1 and q2 are same dimensions. Okay. So I'm writing down now like this, but at the end we are just going to write down the SI. And this is, it's actually a little bit complicated, right? So yes, so I hope Venkatramana, now your query is clear. This is also a constant, but now you know that constants can have dimension. So don't make this mistake, students. This is where, like, it's very silly mistakes. You'll be, killing all your other topics, but this is something easy, but you will be living it. You don't want to do that. So this is the dimension of epsilon. It's going to be kg to the power minus 1, meter to the power minus 3, and seconds to the power 4, and ampere to the power 2. Okay. And you can also actually kind of understand many things from dimensional formulae, like what is the impact of mass, what is happening when changing. But this actually, constants, guys, are constants, don't confuse them. This is just dimensional formula analysis to check the consistency when it comes to constants. We do that. So m to the power minus 1, l to the power minus 3, t to the power 4, and I to the power 2. Even if you don't remember anything, just by heart this formulas that I'm discussing today. Be it 2020 aspirants, 2021 aspirants, or if you're giving exam tomorrow after 2 years or 1 year, you need to know all of this. Okay, when it comes to magnetic fields, we'll be discussing few shortcuts, but electric fields we don't have any shortcut, guys. Okay, these are the shortcuts. Okay, so that means it's m to the power minus 1, l to the power minus 3, t to the power 4, and I square. All right, correct? Let's move on then. This is how you derive it. So yes, this is like the standard way you need to do all your problems, students. All your problems. I hope this must have given you the intuition. And if you're just new to this lecture, just go and also watch, the earlier lecture. Okay. Good evening, good evening, a very good evening. Get started on this problem, students. So find the dimensional formula of magnetic field. A very interesting one, students. Very, very interesting one. So tell me what law you're going to make use of, and what is the thing you know about magnetic field, from where you can see. I told you throughout our discussion, only force, guys. Only force is what we require. Yes, mostly we are only going to deal with only force. So there is a force expression. How do you derive the force due to magnetic field? So any guesses, students? Anyone who knows the answer? What should be the dimensional formula of magnetic field? See, there is a strategy that we discussed earlier. So the strategy is, you do this dimensional formula analysis once at the beginning while you're just starting for your JEE preparation. This is just a message for 2022 aspirants and as well as 2021 aspirants. Okay, both of you can follow this. You do this dimensional analysis, this chapter, once in the beginning and once at the end. At the end means at the end of your physics syllabus. That way you will be able to do it very, very easily. Okay, that was a strategy. That's just a strategy. So let's get started on this. Yes, that's correct. That's correct. Yes. Force is equal to Q into V cross B. Okay. All you need to remember is QVB. That's correct. That's correct, students. Everyone is correct. Yes, that's correct. So that's amazing, Yashwant. That's amazing, Venkat. Very good, Krunal. Very, very good. Yes, guys. So all I remember I told you is just one thing, that is kg meter per second square. And what is Q, coulombs? So you would write it as amperes. Everything in your base SI units. Don't forget this. Don't forget this. That's why I'm discussing the most important points in this chapter, like in this lecture. I mean. And what about velocity? Velocity is meters per second. Just write until here and find out what should be B's unit. One S would cancel out, so you'd get to the power minus 1 over here instead of minus 2. And okay, anyway, I could have cancelled out it over here. Anyway, okay, fine, that's fine. So you could have cancelled out it over here. So yes, So B's unit is kg. It's actually pretty simple, right? Meters per second square, and there is also another meters. Okay, meters also can. Really, very sorry. Yes. Give me a moment. Yes, this. Also this. Three things. What we did was just wrote down the in terms of fundamental SI units, and we derived it. Meter cancelled out, and seconds over here cancelled out, so it should be basically kg second square per. Yes, you go by this. This is the formula you have to go through. So good question. So you have to remember that mu, because you have to derive first of all mu as, okay. In the next question we'll do that. So mu as units, right? You have to either remember the units of mu, or then you can take up that mu I b is equal to mu into I by r. You can simply make use of that this thing, that equation, and move forward. But if you don't remember, this is the way to go about it. Okay. So this is magnetic force, guys. This tells you actually this is the way you derive the magnetic force for like any like moving charges. Okay. So that being said, and a constant magnetic field. Okay. We will discuss that when we move to magnetism, and we are also going to soon move into magnetism. That's the reason also I'm taking up so many dimensional formulas around them. And this should be what? M to the power 1, T to the power minus 2, and I to the power. That is it. Okay. They will also give you J just to confuse you. Yes, that will go super lengthy. You have to remember. So one of the things you can remember about that, when you are asking, to equate magnetic field, like there should not be any length. Okay, there should not be any length. So that way it's only m to the power 1, t to the power minus 1, I to the power t to the power minus 2, and I to the power minus 1. B should be an answer. Right? Yes. Okay, we actually completed it, and there are a couple of ways of doing this. So here is your answer to your question, Kunal. So if you either can go by the magnetic force equation, okay, that is one of the ways of doing it, and the other one is you can go by the Maxwell's equation. So this is one of the most famous Maxwell equation. This says actually there should be a minus. So this says that del cross E is equal to minus dB by dt. Okay, you know how to derive field force by charge. If you're totally new to magnetism, this way you can go about it. Okay, del cross E is nothing but spatial derivative. So this can be like written as dE by dx. Okay, dE by dx means there should be like you'd cancel out the length. Okay, so this is another way of doing it. You can use Maxwell's equation del cross E is equal to minus dB by dt. It's a very interesting formula, guys. I'll just introduce you to something if you're totally new to it. Changing electric fields produce magnetic fields, and similarly changing magnetic fields produce electric fields. Okay. Here it is saying that there is a changing magnetic field. What does dB by dt tell you? dB by dt tells you that the magnetic field is changing with respect to time. It's not a uniform magnetic field, but a changing magnetic field. And changing magnetic field in space produces, electric field. All right. So this is just an introduction to Maxwell's, equation, and this is an interesting. Going forward, you'll see some of those things. So now, how about this, guys? What is the dimensional formula of magnetic permeability? Is it dimensionless? Or do you want to do this? Do you think it is dimensionless? Come on, students, answer this. Yes, okay, a good thing. So Venkatramana has got this really good thing. So what is the SI units of magnetic field? Tesla, guys. The SI unit of magnetic field is Tesla. Tesla, okay. Named after Tesla, the great, electrical inventor, scientist, whatever you can call him, theorist, etc. He came up with the idea of AC current. So it's named after Tesla, who came up with the idea of AC current. But this equation was derived by Maxwell, okay. I think it was derived by Faraday or Maxwell, I'm not really sure. That's a good question. Do it, don't guess it. Whether it should be dimensionless or is there a dimension attached to magnetic permeability? So let's get started on this. Let me tell you something. This is not dimensionless, guys. Magnetic permeability. So that's the thing. That's the thing. I'm again and again taking you through constants. One, we went through gravitational constant. We went through electric permittivity, and now we are at magnetic permeability. And all these three have their own units. In fact, even Planck's constant has its units. Okay, you can later on check it out. So let's get started with this. And so there is something known as, I'm going to introduce you to a law if you're totally new to this. That's going to be nothing but Biot-Savart's law. Okay, you can remember this. Later on, you can we can come to the we will soon start this chapter. We just saw that changing magnetic field produces electric field. There is also a shortcut to do this problem. I'll come to that as well. This is mu by 4 pi I into dl by r square. Actually, I into dl cross r by r cube. For now, I'm just writing it down as yes, that's correct. Yes, Venkatamana, that's correct. Amazing, amazing, really good, really, really good. So I'm going to write down this as just in terms of just form. Okay, I'll write it down in separate colors. This is like the original, expression. Let's not mess it up. So I'm just choosing a different color so that we are going to mess it up just for dimensional analysis. Okay, this means we are just doing the dimensional analysis. And how do we go about the magnetic field? You know what to do for magnetic. You're going to make use of F is equal to Q into V cross B. That's going to be F into Q by B. Okay. Yes, Krunal, you can actually answer from options sometimes. But to come with practice, I guess, for an example, okay, we'll do that during DPP session, okay? For now, let's do, these are like, fundamental things like, that we need to learn. But yes, we'll do a query in the DPPs. Okay, you can, yes, students, you can guess it from the options as well. We'll do it actually for some JEE Mains and JEE Advanced question. Now let's do it, the way we should be doing it. 4 pi does not have any units. I'm not going to carry it over, and I'm going to write down units on each side, just the SI units. Okay, then we'll write down the dimensional formula. So this should be ampere into second. I'm just cancelling it out for the convenience of, dimension analysis. You cannot cancel it out, students. Okay, this should be by meter is equal to, there would be another ampere into second. Sorry, this is just not this ampere, guys. Sorry, it's just amperes. Okay, I is just amperes, right? I is just amperes. Okay, amperes I got from here. I just cancelled it out for the I'm doing dimensional analysis, so I'm just cancelling it out. I'm just deriving the units. Else you can't do that, students. Okay, and also you can't write it like this. You have to write it with all the cross product, etc. And this is kg meter per second. And how about this? This is ampere into seconds. And how about this? Meters per second. We know this. This is going to be A into M. Okay, and this mm cancels out. Okay, what do you have now? Mu's units is kg meter per second square per ampere to the power minus. What is the dimensional formula? M to the power 1, L to the power 1, T to the power. Next class will be on Monday, students. We'll be, and do not miss out the next class. Next class is also very important because you typically even get your questions in JEE Advanced. So next class is going to be on error analysis. Do not miss out. And also, once we get into current and electricity, that error analysis will be useful. And maybe many topics they'll ask you in exam, like whatever way they like. That's a different thing. But yes, it will be very useful even in your exams. Yes, that's really amazing, students. You actually did the question literally faster than me in this case. Okay. M to the power 1, L to the power 1, T to the power minus 2, I to the power minus 2. That should be C. Really amazing, guys. Really amazing. Okay. Not tomorrow, Kunal. Probably on Sunday there would be at 11 a.m. there would be a special class, students. This time, so let's do a special class on the projectile motion, or we'll be doing some DPPs on current electricity or projectile motion. Stay updated on the Telegram channel. I'll keep you posted over there, and you'll get it. So that's it, guys. You need to remember only two things. One is, F is equal to. I'll write it down in red itself. You'll have it anyway. One is your F is equal to Q into V cross B. And the Biot-Savar's law. These are all vectors actually. You're not writing it down that way. So that's it. So yes, so these are the two things that you need to remember, and you can derive the magnetic permeability. And there is another way. So this is going to be another awesome method. If you don't remember, if you haven't studied magnetism at all, okay, let's assume at the end of, so few things that we are discussing is assuming that you haven't. I'm expecting that especially 2022 aspirants don't miss out magnetism because it's a very interesting chapter. Very interesting, means very interesting. And guys, let me tell you something amazing about it. Once you understand magnetism, it will be as if things are becoming very clear to you. Even electricity, electromagnetism. I mean, this electrostatics, everything will become so clear to you. Don't miss out magnetism. But if at all you're missing out magnetism, so this is one of the formulas that you can apply. So this says that what is C? C is speed of light. Speed of light will depend upon the medium. So 1 by under root mu E. Mu is magnetic permeability. And epsilon is electric permittivity. And using this formula, you'll come across a very interesting concept known as negative. Not now, but maybe later in your maybe if you're in electrical engineering, or if you take up physics as your future pursuit, you will use this. If you do a research in something known as metamaterials, you will explore this formula a lot. You'll play around with this formula, guys. Literally, you'll play around with this formula. You'll try to achieve something known as negative refractive index. Okay, and there you'll observe that supposedly the light will slow down, okay, from what it should be. So that being said, this is electric permittivity. Interesting concept, huh? Just like Maxwell's equation. These are all like little advanced things that may not come up in JEE, but this is something very good to know, students. And especially if you haven't covered magnetism, then you can make use of this formulas to derive. Now, electric field permittivity, okay, or electric permittivity. Okay, this is actually very interesting. Hi. You're welcome, Kunal. Don't worry about it. We'll cover everything. You need not worry about it. So, what is Weber's? Any guesses? Any guesses, students? Any guesses? Any guesses? What is Weber's? Any guesses, students? What is Weber's? Weber? Where does this Weber come from? You heard about Tesla. Is there something known as Weber? What is Weber's? Is it a dimensionless thing? Try it out again. Of course, every answer is not going to be D, right, Kovi? So, what is Weber's? Okay, let me first of all tell you, Weber's is an SI unit of something known as magnetic. Okay, Weber's is an SI unit of magnetic flux. Actually, quite a simple concept, guys. We know what is magnetic, how to derive magnetic fields dimension formula. What is generally flux? Flux is actually you're calculating the number of field lines in an area. Okay, so if I'm talking about like any general flux, I'm assessing how many field lines, wind field lines, or velocity field lines, or electric field lines that are passing through any area. So if I know one field strength, what would I do? I would basically multiply the field into area to derive flux. Got it? Good evening, Roshan. Good evening. I'm good. How are you? And how are you all? I hope everyone is staying safe, and you should take care of your health, guys. That is also very important. Keep learning. That's also very important. Yes. No, not yet. You didn't get the answer yet, Kobe. Try it out again. Try it out again. So I'm just introducing to your concepts. If you're 2021, 2022 aspirants, I'm just introducing you to the concept. So Weber is an SI unit of magnetic flux, and how do you calculate Weber is what we just discussed now, right? You'll multiply field into area. So I'm going to talk about magnetic flux. Going to be B, actually it's B dot. You're actually calculating only those field lines going across that area. But in our case, we are going to do dimensional analysis. So we'll mess up everything, we'll spoil all our concepts and just try to derive the units. So our objective is to only derive the units. Okay. So how do you calculate for magnetic field? You know what to do. It should be F divided by Q into V, since F is equal to Q into V cross V. So how many of you actually think we need a class on basic mathematics? Students, this is important actually. This is important because this is there in your syllabus, so they will ask you anything, So don't ignore these things, and it is very, very important, guys. I'm directly going to write down the dimensional formula over here. It's actually simple. You thought what is flux. Now if you know what is flux, you can actually derive this thing. So the entire reason I brought up this new kind of important quantities is I went through your past papers and I saw that like things have been asked around this magnetic permeability, electric permittivity, some farads we did in the last class. You can go through it, but anyway, this is the way to go about it and derive them. Okay, these are important actually. Okay, and it's easy actually. So here A is area, guys. So I'm writing it now. I'm going to write it down as amperes. Okay, this is not amperes. Sorry, this is area. And I'm going to write it down as meter square. And this is V is velocity over here. This meters per second. All right. And what is Q? Ampere into second. Okay. This is SI units. Okay. And this is expression. Don't mix them up. Okay. So yes, what should be the units of Weber's? So Weber is actually an SI unit, students. Weber, Tesla, Pascal, all are SI units, but they are derived SI units. We are trying to express this derived SI units in terms of, fundamental SI units. That's our objective throughout this chapter, right? I mean, throughout this dimension analysis. kg, once you will have 1 meter cancelled out over here, and you will also have second cancelled out over here, and you have meter square, second square. Actually, it was pretty easy, right? Don't miss out, things like this, because at least if you haven't covered it anywhere, do cover it now, because like you get questions around them, guys. They are like, easy questions, and you will see that, you could have not even spent your energy and you could have cracked these questions. That's it. That's about Weber's. M to the power 1. So one of the things is like what Kunal asked. So you can go through the options and see where there should be t to the power minus 2. As soon as you get few things, you can eliminate them. Okay. But anyway, it's best to always write it down completely, because your questions may not be necessary like this. Your questions will be something like like they are asking you to express, given some random dimensions of B, they will be asking you to express phi in terms of B, or B bus in terms of magnetic field. So m to the power 1, L to the power 2, t to the power minus 2, a to the power minus 1. So which is that one? M to the power 1, L to the power 2, t to the power minus 2, a to the power, I to the power minus 1. So it should be D, guys. Alright, that's what we derived, right? M to the power 1, L to the power 2, t to the power minus 2, and I to the power. Oh, this should be I. Don't forget to do this. This is a mistake that happens often, so you should change it to I. Okay. Alright. Thank you, Roshan. Thank you so much. Thank you so much. Okay. No, topic is not Weber. Topic is dimension analysis. Okay. So that being said, that is how you derive Weber. You basically need two things. You need to know two things. One is, F is equal to Q into V cross V. This we have done it the third time, so I guess you all remember now. And flux, do remember, it is nothing but I just taught you the concept of flux. Flux is basically counting the number of flux line through an area. Sorry, a field line through an area. In this case, its magnetic flux is different from electric flux, guys. Okay, magnetic flux is different from electric flux. Okay, so get the point, and you can also work around magnetic flux. Maybe if we have time, we will also do for magnetic electric flux. So always try to derive in the terms that you get. Okay. So what is the dimensional? Okay, what is magnetic field strength? So this is the relation you have, guys. P is equal to mu into H. Okay, where P is the magnetic field. Okay, so this is the expression that I'm going to tell you. Magnetic field strength is basically telling you, irrespective of the medium, what is the strength of your. So if I'm going to do this, so let's say if I'm going to derive a magnetic field, irrespective of the medium, what is the strength of your field? So that is about magnetic field strength. All right. Try it out again. Try it out again, Roshan. So what should be the answer in this case? Which formula you are going to use, guys? Which is the formula that we just learned? We need to make use of this in the dimensional analysis. Okay, so I told you one thing, that is B is equal to mu into H. And do you remember Biot-Savart's law? Do it again, do it again, do it again. So yes, in questions like this, you know it is independent of mu. Okay, once you start solving this, you will feel that this is very easy, guys. Very. The easiest dimension analysis today we are doing is this magnetic field strength. Honestly, this is the easiest one that we are doing today. Okay, if you remember Biot-Savart's law, it's mu by 4 pi into IDL by R square. Isn't it? That's it, right? So while calculating magnetic field strength, you're not worried about the permittivity. It's a simple problem. Now tell me what should be the answer? Quickly means quickly. What it should be? L is length, R is also some distance. So what should be the answer? Shouldn't it be just amperes? Just for dimension analysis sake, I'm just cancelling it out. Per meter, that's it, right? That is it, students. That is it. So you can remember one of the dimensional formulas, that is magnetic field. Without any efforts, you can remember the dimensional formula of something after your base dimensions or fundamental quantities. That is going to be your magnetic field strength. Really easy. Ampere per meter. That's it. Mu would get cancelled out, right? And I'm going to calculate H. So there is a common mu. Irrespective of the medium, what is the strength of the field? So you can understand things like this once we start working around dimension analysis. So that being said, what should be its dimensional formula? Dimensional formula, I don't need to write anything actually. It's I to the power 1 and L to the power minus 1. Pretty simple, huh? The most simple one that we have done today, isn't it? So one more thing is, guys, if you even remember a small thing like this, you can derive the formula for permittivity very easily. Okay, many times, many students don't remember, how to derive for permittivity. At the end moment, they get confused around, Biot-Savart's law. But you can just make use of this specific thing to derive anything that you like. What should be the answer? L to the power minus 1 and e to the power 0, I to the power. These are just given to confuse you, okay? These are not necessary. But if I had given you just that, you would have identified very easily. So that is about magnetic field strength, students. That is all it is. Not much effort, but you can do it. Okay, so all you need to remember is B is equal to mu into H and the Biot-Savart's law. Okay. So if you remember both of them, so if you're totally new to this topic, or if you're totally new to IIT JEE preparation, just go through this entire lecture again. Just you should go through this entire lecture again, and not only that, also make sure you're noting down everything as we are going through this. Okay, this Biot-Savart's law, force on a charge in a moving magnetic field, and Coulomb's law. These are some things that needs to be introduced in this dimension. Okay. Yes, only D is possible. So yes, now we are going to deal with something interesting known as Henry. What do you think is Henry? What should be the dimensions of Henry, and what is the way to move about Henry? Is Henry dimensionless, or does Henry represent something? Okay, we have near about covered, like many things around magnetism actually. This will be like, actually this needs to be taken very slowly when it comes to magnetism. Each one of them is a law. Each one of them has many model problems around them. But when you're coming to dimension analysis, you need to remember some formulas. Sure. Are you guys sure? How did you go about it, Prabhat? What is the way that you're going to do it? What is Henry? What is the unit? Like Henry is units of something. So we are just talking about dimensions of Henry means it's a unit. Okay, dimensional formula of some physical quantity means it's a physical quantity. What is the Henry? That's just like that's just English, but anyway, Henry is SI unit of inductance. Okay. So I'm going to tell you something interesting that is known as Lenz's law. Many laws in one day. That's never going to happen again. Don't worry. Lenz's law. And this Lenz's law says, actually, if you notice, the formula is going to be super easy, but we need to spend some time to derive this. So Lenz's law says that EMF, electromotive force, which we generally denote in volts, is equal to L into di by dt, where I is current, dt is time. T is time, you know that. I is current. EMF is equal to L into di by dt. And this is also something known as an electrical component. What is actually this? There is something known as inductor. Okay, students. So this inductor is a weird, like an electronic component, just like your capacitor. Capacitor stores energy in the form of, like electrical fields, whereas inductors store energy in the form of magnetic fields. Store means they don't literally store. Like changing magnetic fields do produce some current in coil, you know that thing. So from there comes the Lenz law. Awesome, Prabhat. But is it 1 by or it's R into some seconds? Try it out. So EMF, what is the? I'm just going to directly write down. I'm going to mess it up. I'm going to mess up the loss. So let's choose a different color to mess up things. So this is volts. This is amperes. Okay, let's write it down as I and T. Time. Still we are in that place. So V into T by I. What is V by I? V is equal to IR is Ohm's law, right? Your Ohm's law says V is equal to IR. Okay, very new to this, just few things, just bear with me and try to get this point. If you're totally, a 2021 aspirant, you must be knowing all of this. This is Ohm's law. No. Okay. Okay, we'll come to that point as well. We can do that way as well, Prabhat. So yes, first let's do it this way. I'll come to your point. So there is something known as RC and the RC constant. Using that also we can derive it. Okay, that's actually a very interesting perspective of going about this dimension analysis. Actually very interesting, guys. Okay, this is L is equal to V by I. No, actually that is not how it works, right? So what is this? Resistance into time. I've taken it the other way around. Yeah. What are you asking? No, I don't know. No. That is fine. That is fine. If you're totally new to this, it's fine. It's not inverse of resistance. Okay. So L is equal to R into T is something that you can remember. Why there is something known as RC constant. So just for now, remember these things. Okay. RC's unit. What is this? R is resistance. C is capacitance. This yields nothing but this. The SI unit of this is time. I mean, like seconds. Dimensional unit is e to the power 1. SI units is time. Sorry, SI units is second, and like physical quantity is time. And similarly, L by R also gives you time. This is another way of remembering things. Okay? You can remember it this way as well. Okay? This is also something that you can note it down. Okay, and especially if you are in second year, you can go by this formula because you have already done inductance. If not, just remember Lenz's law, guys, because I know most of you might be from 2022 batch, so that's the reason I'm introducing you to new laws. Lenz's law, it's a very interesting thing. Change in current, if there is an inductance, if the coil is turned around many times, it will have a voltage across it. So same thing, like that, it comes from the Maxwell's equations, right? Changing electric field produces magnetic field. Changing electric field, current is changing. What is current? Current is nothing but a manifestation of electric field. Charges are moving, it's a manifestation of electric field. Where this electric field is changing, it's producing a magnetic. Okay, no, I is changing means manifestation of a changing this thing, magnetic field, which is producing electric field. Okay, so yes, you can do it that way as well. So it should be what? Ohms into seconds. So we need to derive for ohms actually. Okay, but rather what I would do is I would not go into the entire thing of writing down RT and things like this. There are the other way to do it is, okay, I'm going to write down one more formula, students. So one more formula, another formula. This formula comes from electrostatics. F is equal to Q into V into D, where D is distance, Q is charge, V is your potential difference. Okay, that means V is equal to F by QD. So yes, guys, so what are we going to do? We are going to spoil our laws and derive something interesting. That is going to be the dimensional form. Okay, because ohms you have to, so other ways ohms you can go into I square R, but yes, this is something that this is something that you should know. Okay, and that being said, let's derive the formula again and write it down. L is equal to F, because I told you, I promised you in the beginning, we are only going to make use of fundamental units and force, nothing else. That's the reason I'm going to start with this. It's going to be, sorry, I'm going to write this again. Looks messy. All right. Ankur, yes, soon we'll be there. And morning classes, Roshan, soon that will also happen. Okay. So that being said, this is force divided by QD, because see, I honestly don't remember units of anything other than force. So that's the reason I'm taking you through this kind of dimension analysis. This makes things very easy. Force, it's kg meter per second square. Mass into acceleration. Charge, what is it? Ampere seconds. And what about d? Your d is distance. This d is actually distance, guys. Okay, no other d, that's meter. Okay, again another ampere. Okay, that being said, this meter you would cancel out. There would be an this would go on the top, so s to the power minus 3. So inductance unit is something like this, kg. This is SI unit in base quantities. Okay, this is not really the units, guys. The real units is Henry, right? Real SI units is Henry. You are not going to write it all the time this way. You're going to express it in terms of Henry. Minus 3. Give me a moment. So we have pretty much covered many concepts in one day, but this is not the way to cover concepts, students. This is the way to just do the dimensional analysis. Actually, one of the worst ways to cover any concepts. That's it. Well, good Roshan, I guess you must be, Yes, Prabhat, yes, that's true. Potential difference and EMF are not same dimensionally, they are same. Okay. EMF just go through the current and electricity classes, students. If you are even in 11th class, don't worry, go through the current and electricity classes. So this should be m to the power 1, t to the power minus 3, and I to the power minus 2. Okay, m to the power 1, t to the power minus 3. A moment, we missed something. kg meters per second. There should be a time, right? We forgot second. Be minus 2. Let's do it again. Just give me a moment. Let's do this. Yes, you can cover current and electricity classes, students, so that these things don't seem very unobvious to you. So yes, kg meter per second square is something that we remember. Q by d we remember. I is something amperes, like ampere into second. This distance is meters. Okay, this is meters written over here. I'm cancelling it out, meters and meters. Yes, maybe we didn't take down the right kind of options. Okay, seconds would get cancelled. You just keep it as okay, kg second square ampere square, ampere to the power minus 2. Okay, I guess we haven't taken down the right kind of answer. Okay, the option is not available, but anyway, do remember how to do this problem. You do EMF is equal to, that is nothing but potential difference, equal to potential difference. EMF and potential difference are exactly not the same things. Once you get into current and electricity chapter, you would understand that. So anyway, the options are not correct, I guess. So let's just write it down over here. EMF is equal to V equal to L into di by dt. And the other way of doing it is just derive it from this is known as Lenz's law. You can derive it from time constant as well. This is nothing but L is equal to V by I, dimensionally writing it, into T. Okay, and V is, you're going to write from F is equal to QVD. How do we get this QVD? We got F is equal to QE, right? That means this is true when it comes to your current and electricity, E into D equal to V. Okay. I think I didn't get your question. Question, current and electricity is completed. Di by dt, not dr by dt. Di by dt, guys. Who told you dr by dt? No, di by dt. Okay. A moment. QED. I guess this is just QE and E to T or E into T. Electric field into distance is equal to potential. Yes, we did some mistake over here, guys. E into D is equal to potential, and that is the D by D, I guess. That is correct over there. QE is force. Just give me a couple of seconds. Okay. Is equal to Q into E. Electric field into distance is equal to, that is correct. This should be QV by D, I guess. Okay, QV by D. That way to redo this. A great mistake. Or else, okay, let's check it out the other way as well. If you're missing something like this, okay, I think, yes, that's correct, right? Yes. I'm really sorry, guys. So this is incorrect. This should be, because what is potential? Potential is nothing but if you move a charge across some potential, it's equivalent to some work done. So here it should be QV by T. Okay. So yes, I'm really sorry. QV is work done, basically. QV is work done. Let's do this again. I hope these things are clear. There's this part. Do it from the beginning. So I'll tell you the second way of doing. If you're getting confused around Henry, we can do it in the second way. So one is, you can go through the Lenz's law. It says that changing magnetic field produces electric field. This EMF is equal to L into dI by dt. The other one is work done is equal to force into displacement is equal to Q into V. They are the same things. Okay. I mean, like dimensionally, they are the same things. If you're doing some work against some force, it's the same as doing some work against some potential with respect to charge. So that way, potential should be like F into D by Q. Okay, from here we have L is equal to some V by I into dt or T, which can be written as F into T by Q into I into dt. Okay, that tells you, you can write down this as T. I'm sorry for confusing you. I'll tell you the other method of doing this, even an easier one. Let's do it that way as well. That is going to be faster than this, but that time we are not going to make use of force. I think we are simply writing it. So from here, I'm going to write down the dimensions. Dimension in this case should be like kg meters per second, and this is dt. D is distance, not dt. This is distance d. So another meter would come over here, and there would be time. It's going to give you seconds. Okay, F into d by q. We got it from over here. So again, what we need to do is ampere second into ampere. Second cancelled out. This should have been a very easy question, but we messed it up totally. That would give you, this is SI unit of inductance. How you have farads, that way you have SI unit of inductance. Just a moment, guys. So that should give you the SI units is going to be kg meter per second square, meter square per second square. Little complicated, I guess. Ampere square. Okay. Dimensionally, how it can be written, we'll verify the dimensional correctness, okay, of our derivation. So L to the power 2, T to the power minus 2, and I to the power minus 2. Small mistake, so don't make this mistake. Work done is equal to force into displacement Q into. Times copy, yes. Okay, so yeah, a huge blender. Okay, I'm really sorry, but this should be the thing. Work done is equal to force into displacement Q into. Okay, if you're using force, let me tell you the other way of doing it. So the other way of doing it is going to be something like this. We know already this thing. There's nothing but V by I into T. So we just derived this. Okay, and this is nothing but R into T. Okay, time constant is L by R. Now I squared R is equal to power. There is something known as power, which is nothing but I square R. And what is the units of power? Power is nothing but work done per unit time, energy by time. Okay, power is energy by time or work done by time, which is nothing but force into distance by time. All right. So that way you can derive the units of R and simply multiply it by T. From here I'm going to write down the units of R, which is going to be F into D by T, okay, into 1 by I square. I square, ampere square, because why I did this is it's very direct right now, okay. kg, so this is power formula, this is energy per time. Power formula is I square R. Once you can check out the current and electricity chapter, okay. I squared R, and the power is energy per time, which is nothing but work done per time. Work done is force into displacement by time, okay. And what this should be? This should be kg meter all correct though. No. R is equal to I square by R. R is nothing but energy per time. That is correct. That is correct. Yeah. This is nothing but second kg meter per second square. Okay, everything is correct. Down and down. Hence, kg meter per second square into a meter, okay, by second by I square. Okay, and this is for resistance. For inductance, it's going to be R into T. So you can cancel out this S. Basically, it's nothing but kg meter per second, meter square. I'm directly writing it down as meter square, ampere inverse square. Okay, so that should be, we got both ways this answer. But anyway, so I guess we messed up a little bit in the basic things, but we need to correct it, guys. We correct it. We have noted it down. This is fine. Okay, this is the other way of deriving Henry. Okay. And that being said, yes, guys, this is how you derive again the other way of deriving the Henry, because this is nothing but SI unit of this is Henry is the SI. All right, m to the power 1 L squared T to the power minus 2 I to the power minus 2. We got it both ways. The answer is going to be T. Okay. Yes. So yes, students, that is how you do this one. And now coming to a confuse me challenge problem, which of the following physical quantities does not have dimensions? Solid angle, relative permittivity, or Poisson's ratio, or all of the above. So anyone watching this video, try to guess this answer. So which of the following quantities does not have dimension? We discussed about dimensionless quantities. It is possible to a few constants or few things to not have any dimension. So which among those is that one that does not have any dimensions? Physical quantities we are talking about, not about constants. Solid angle does not have any dimensions. It's a mathematical expression, that's it. It's a supplementary quantity, and solid angle does not have any dimensions. Relative permittivity does not have any dimensions. Okay, relative permittivity, magnetic susceptibility, and Poisson's ratio also does not have any dimension. Okay, it's basically strain by strain, hence no dimension. Lateral strain by longitudinal strain. It's basically strain by strain, so you won't have any dimensions. And yes, all of the above is the correct answer. Alright. So which of the following physical quantities does not have dimensions? Solid angle, relative permittivity, relative permeability, Poisson's ratio, magnetic susceptibility, and also your refractive index. Okay. Any of these do not have any dimension. And also your solid angle and your 2D angle. And why do we do this dimension analysis? To actually check the correctness of an equation. Just like how we got stuck in our in our derivation for the dimensions of this thing Henry, we got that something is going wrong because it is dimensionally not valid. It states that on both the sides you should have a dimensionally valid quantity. For example, Q into V should have been F into D. There we did the mistake and we understood, okay, the dimensions are not matching. Something has gone wrong. So that way, dimension analysis helps us a lot in understanding, the correctness of an equation, and this is known as principle of homogeneity. And it also helps us derive the value of constants, or the dimensions of the constants, and it helps us find out the conversion factor from different units to that same unit. Okay, let's say I have to make FPS unit to SI units, then I can make use of dimensional analysis. But anyway, this is very theoretical. Let's get into actually something very interesting known as significant figures. So today we are going to explore something interesting known as significant figures. So why do we use significant figures? Significant figures is basically telling you about the precision of a measurement or an accuracy of a measurement. More the significant numbers means more is better if you're measuring accuracy. Okay, for an example, if you measure just using your arm, you can probably state something in terms of like this much in meters is what it should be, but that is not accurate. But if I had used a vernier calipers to measure some thickness, it's very accurate. Like vernier calipers and screw gauges give you more number of significant numbers. So it's a very accurate measurement. And any additional significant figure on the mathematical expression. So this is one of the clauses. When I'm talking about significant figures, there is one more thing. So if you're multiplying two quantities, and if one of them have a lot of significant figures and the other one does not have a lot of significant figures, the one with the lesser significant figures actually tells you the accuracy of the measurement. Okay, so any additional significant figure on the mathematical operations other than what we should have expresses inaccuracy in the measurement. Okay, that is one of the most important things. So let's say if I want to calculate an area of a square or rectangle, one of the sides is like, let's say 1.25 meters and the other side is I'm just saying the other side is just 4 meters. We know, of course, A into B should be the area, and that way we should getting our area as something like 5 meters. But in reality, it's not going to be 5 meters. Okay, there might have been some inaccuracy in this case because we have just expressed it as 4 meters. It could have been like 4.01 meters. If I told you it is 4.01 meters, or if I told you it is 4.00 meters, then it is more accurate form of expressing things. No, Aryan, not just dimension analysis. Error analysis is a very important part that will also come in your exams. Significant figures, you need to just understand the basics. Within next 20 minutes we'll be covering the significant figures. You should understand the basics though, like around significant figures, how do you round off things, because actually they will mix up the significant figures in some of your calculations. Okay, it might not be really relevant, but they'll mix it up in your options and they'll give you multiple options that are correct, but it would be only single correct options. Then you have to make use of significant figures to answer your this thing. Dimension analysis is one of the things that you will get. Error analysis is something that you'll get. you may get a question on vernier calipers or screw gauge. Okay, from this chapter, these are the places that you'll get. Significant figures are not really the topic from which you directly get questions, but there will be like 4 options. It will be only one correct answer, and then from using the significant figures, you'll identify which is the correct answer. Okay, so yes, significant figures help you express the accuracy of the measurement. More the number of significant figures means better the measuring accuracy. And let's get started with something. So here is this expression. The one that is marked in red are the significant figures. This is not significant, this is not significant. What do I mean? What do I mean is that these zeros before this 50.0230 does not tell you the accuracy. And similarly, this does not tell you the 10 to the power 8 does not tell you the accuracy. So this is not order, and these are some zeros before your number. These are also called leading zeros. So what do I mean by leading zeros and order does not tell you the accuracy? Of course, they tell you the value. Leading zeros, of course, don't even tell you the value. Order tells you the value, but it is not accurately telling you the value. Okay. So in this case, if you have noticed, this zero is significant. That means I can say confidently that I have measured until the 0.0230. Until these 4 decimal places I have measured things. So that way, this measurement is accurate, and this significant is telling me about the accuracy. 10 to the power 8 can be some unit conversion, can be something just if I'm going to say it is 10 to the power 8, maybe it's not very accurate. Okay, value is correct. Just like what we saw earlier, the value should have of the area of that rectangle should have been 5 meters square, but maybe it is 5.01 meters square. We didn't measure beyond that 4 meters. If I told you it is 4.00 meters and the other one was 1.25 meters, then we have accurately measured both of them, and once we are deriving that value, it is going to be 5 meters square. But let me tell you something, area as such cannot be it's not a very accurate measurement. What do I mean by not an accurate measurement? Significant figures, etc. We'll move forward and understand each and every. Okay. So this is the thing, guys. So this order is not really telling you the accuracy. It's telling you the value. It's conveying the value, but it's not talking about the accuracy. These zeros don't mean anything. But whereas you have measured it until that 0.230 value. Okay. Hence, this is accurate. This is an accurate form of representation. So yes, when we are talking about significant figures, leading zeros are not significant. What do I mean by leading zeros? Leading zeros, I mean, is like the zeros that come in the beginning. Okay, these zeros are not significant. Okay, maybe we have just measured that 6.5, and trailing zeros without any decimal points are not significant. So these are some rules, guys. So don't get confused with the rest of your topic, but these are some rules. And these rules are applicable when you are converting it from one unit to the other system of units. Okay, that is when these rules are very much applicable. That is where you will make use of them. And trailing zeros are not, without any decimal points, are not significant. In this case, this is not significant. 7.3 is significant, but 0.0 is not significant. It's not talking about the accuracy. Maybe it was something like 7,301, but maybe you just measured it approximately 7,300. Okay, and order of magnitude is not significant. We just saw that thing. All right. So yes, leading zeros are not significant. 0.065 in this 0.0 is not significant. Whereas trailing zeros without any decimal point is not significant. Whereas if you have a decimal point and there is a 0, that is significant. In this case, if you are noticing this specific thing, 3020 decimal 40, this 0 is significant. Okay, you know this thing, all non-zero digits are significant. If I'm expressing something in terms of non-zero digits, then I've measured it. Okay, I'm stating 0 to avoid the hassle of measurement to give out some like just approximate value. But if I'm going to express it in terms of non-zero digits, I've probably measured it, or maybe I've rounded it off, but I've measured it. And zeros between any two non-zero numbers or significant digits are significant. Okay. And trailing zeros after decimal points are significant. We just saw that. So this zero is significant in our case. Okay. And what do I mean by any zeros between two? So these are some rules. Okay. This is significant. You are measured until 2. That means these zeros are also you are measured with accuracy. Here you are measured until this 0.40. So this 0 is significant. Alright. And one more interesting thing, students. What about in this case? How many significant digits are there? Can you start commenting it, students? Like, how many significant digits do you see in this number? Okay, this is the question. Can I say that these three are not significant? Only these three are significant. These leading zeros are not significant. Okay, maybe I've just measured only until 0.00505. Okay, but these three digits are only telling me about the accuracy. So there are only 3 significant digits. Alright, so there are only 3 significant digits. All these leading zeros are not significant. And similarly, in this case, how many significant zeros are there? See, this leading zero is not significant, but this zero is significant. That means in this case, there are 4 significant digits or 4 significant figures. Okay. So that is the thing about significant figures. Now, in this case, how many significant figures are there? 5 significant numbers or figures. This is not significant. Okay. So in a way, we are accurately measuring it until here. Then we are probably raising it to the base to the power 10 to 8. That is because maybe that it's some units or maybe something that we have converted, but this is something that we have accurately measured. So let's get started with some challenge problems, students. So the number of significant figures in this given expression is how many? Whether it should be 2, 3, or 5, or none of the above. The answer really not given to you. So in this case, so anyone, any guesses? See, in this case, if you are seeing, there are 5 significant digits. This is not significant. This 0 is not significant. This, yes, no, this is not. Yeah, this is 5. That's correct, Aryan. Yes, 5. Then let's move on to the next question. So, how many significant figures are there in this one? How many significants are there in this number? We're just talking about significant numbers. I'm not asking you the value. Are you sure? So, these 3 zeros are not significant. Only 5 is significant. Any zeros, any trailing zeros, 1, yes. It should be only 1. Because any zeros that is following any non-zero numbers, but not between any non-zero digits or significant figures, that means they are probably not expressing the accuracy. Okay. If there was a decimal point, just a decimal point, yes, it would have been accurate. If I told you it is 5000 dot 0, then there was 5 significant figures. But if I just told you 5000, maybe only 5 is what you have accurately measured. Rest you haven't measured properly. I mean, this is just a way of telling it, but as such, understand that there is only 1 significant figure. If I put a decimal point in front of it and added a 0, then there is 5 significant digits. In this case, you can accurately, or like you can confidently state that you have measured until that 5th digit dot 0. Okay. Let's move on to the next question. So in this case, how many significant figures are there? 1, 2, 3, 4, 5 and 6. In this case, you have 6 significant figures. Alright. In this case, you have 6 significant figures. Whereas you saw the same 5000 earlier expressed only had one significant figure. If I added a decimal and expressed it up until the second decimal point, that means I have measured it until the second decimal point. I have measured it until here. I measured it until here. Right? No Vaishnavi. In this case, there are 6 significant figures. Okay, 5.00. So these zeros are between. Let's understand this point. These zeros are between some significant figures. This is also significant. And this is also significant. That means these zeros are also significant. So in total, there are every digit over here is significant, every figure over here is significant. So there should be 6 significant figures. Alright. So these are some things that you need to know. And in this case, how many significant figures are there? This is not significant. This is not significant. Okay, you can pause and do it. But there are only 3 significant figures, students. Okay, there are only 3 significant figures in this case. That's correct, yes. So yes, how about this then? How many significant figures are there in this case, students? Aryan, any guesses? How many significant figures? Vaishnavi, how many significant figures in this case? Yes, only 2 significant figures. These all are not significant. This order is not significant. Only 2 significant figures. Alright. These are all types of cases. Now, how about this? How many significant figures are there? Are you sure, Aryan? Only 1 significant figure? So the thing is, this expression has infinite significant figures. What do I mean by infinite significant figures? See, we have measured the speed of light. We are saying it is 3 into 10 to the power meters per second, but we actually don't know whether it is 3 into 10 to the power 8 or some 2.9898 something like that into 10 to the power 8 meters per second. Okay, so I asked you specifically, what about the speed of light? Yes, it is c. So when we are talking about speed of light, we haven't measured it yet accurately, right? We are just guessing the value. We are just guessing the value that it is. I mean, this is the accurate value. I mean, still it's not the precise value. Okay, this is not up to decimal value. It's just somewhat approximated value. A speed of light, what we measured until now or what we learnt until now, is only an approximate value of speed of light. Okay, there are infinite such decimals attached to it. So we generally say that, like speed of light, anything that you have measured like in universal truth, the values that come from universal truth, has infinite significant figures. Similarly, area, in that case I said A into B. In that case, area also has infinite significant figures. Alright, how about this? Number of significant figures for the given expression of volume of sphere. Take pi is equal to 3.14. How many significant figures are there in this case? 1, 3, 5 and infinite. Yes, it is D. So the thing is, that's amazing, Aryan. So the thing is, we just discussed area, speed of light, anything that we are measuring is not very accurate. What do I mean by not accurate? This is the value 4 by 3 pi. I mean, for a sphere, this is the radius, 3 is the radius. But the thing is, we are guessing that it should be near that value. Maybe it is not, exactly that value. So in this case, even the volume of the sphere is an approximation. Okay, pi itself is an approximation actually. Pi itself has infinite significant figures. Okay, pi itself has infinite significant figures. Understand that point. And what about this? A is equal to root 8. Then in that case, how many significant figures are there? Again, infinite significant figures. The reason is it is 2 root 2. Okay. And once you get to know the root 2's value, you'll understand as infinite significant figure. Okay, there is no, like in few decimal points, you can't really express root 2. Okay. So that way, this expression also has infinite significant figures. You can't accurately express the value of root 8. And that being said, any universal constant like Planck's constant, your like magnetic permittivity, permeability, or electric permittivity, all have infinite significant figures. The gravitational constant, value of gravitational constant. Anything. Every universal constants have infinite significant figures. They are only measured up until some accuracy. The exact value is unknown. Speed of light. Okay, refractive index of a material, dielectric constant of like an insulator. Everything, every universal constant or a measured, like pre-measured quantity, like let's say properties, are have infinite significant figures. Okay, so this is something that we should know when we are talking about significant figures. And what is the other thing about significant figures? So let's say I have a quantity in SI units and I'm going to convert it into CGS units. Then in that case, I should make sure that the number of significance that was there in the SI unit should be the same as the number of significant figures in the CGS unit. If they are not same, then my expression is inaccurate. Okay, they should be same number of significant figures. If I don't have the same number of significant figures, that means my measurement is inaccurate. If this is accurate, if I have the same number of significant figures, if not, it is inaccurate. So while converting to the other system of units, from one system of units to the other system of units, the significant figures should remain the same. Yeah, Pushpalata, what's your query? And that being said, friends, let's get started with the problem then. Why don't you start answering this problem? There is something known as, A is equal to given to you as 52040 kilometers. So what should be the answer in this case? Only one correct option, guys. What should be the answer? Yes, yes. What's your query? What was your query? So now, awesome. Yes, that's correct. That's correct, Pushpalata. Yes, that is only 4 significant figures should be there in your expression. Okay. No, Aryan is C. There should be, okay, how many significant figures are over here? 4. You have 4 significant figures, right? And you should also have only 4 significant figures while you're converting the unit. So yes, the answer is C. That's correct, Pushpalata. So there should be only 4 significant units. This is not significant. In this case, you have 4 significant units. How about option A? Option A, you have 5 significant units. This is incorrect. And how about this one? You have 1, 2, 3, 4, 5 again. So 5 significant units. This is also incorrect then. Okay, this is also incorrect. This is also incorrect. You have 4 significant units. And yes, the conversion is correct. So that means this is the correct answer. That's amazing, guys. Amazing. Really amazing. And how about this? This also has 5 significant units. Okay, 5 significant figures. I'm really very sorry. Okay. And how about this? Which is the correct answer in this case? Given to you as A is equal to 300 seconds. Which of the following options are correct? Yes, Pushpalata and Aryan, can you guess the answer? What should be the answer? I'm converting seconds. Here S is nothing but seconds. That's correct, yes. Amazing, 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 amazing. It should be B. It should be B. Here you have 3 significant figures, right? This is wrong, right? Because you have 3 significant figures, whereas in this case you only have 1 significant figure, and in this case you have 1 significant figure, right? This is not significant figure. That's correct, Aryan. Pushpalata corrected. It should be B, right? This is not significant anyway. All right. Yes, students. That is all about significant figures. Now let's come to something interesting known as rounding off of numbers. There are only few rules around rounding off of numbers. We will understand it very quickly. So any number to be rounded off greater than 5. So let's say I have to round off some random number. Let's take it up as 4.5432. Then I'm saying that I have to round it off to 3 decimal places or 2 decimal places. Okay, I want to round it off until this 4. Okay, so in this case it is less than 5, so I would directly write it down as 5.54. Okay, and if it is greater than 5, for an example, I have something like 4.67, and if I round it off to 2 decimal places, then I would write it down as 4.57. Okay, so this is the significance of rounding off, guys. Okay, so rounding off lets you express your values with some accuracy, like what should be that accuracy is, and there are some standard sets of rules and regulations that you need to follow. And let's say you have to round off 5. Okay, you have to round off 5. It is following any number greater than 0. For an example, let's say I have something like 4.651. If I have to round it off to 2 decimal places, it is going to be 4.6 4.66 because this 5 is followed by something greater than 0. Okay, now let's say I have to round off this, to some 5, and so this again in turn would be like 4 point. Sorry. I have to correct this. Let's say I have to round it off to 1 decimal point. Then I would write it down as corrected, guys. So it should be 4.7. All right. I can't say it is 4.6 anymore because this is followed by 5. Now if it is 4.650 where 5 is followed by 0, then what would I do? Then I would check this number. The idea is to always keep this as even. Okay, you must try and keep this number that where you have to round it off as even. In this case, it is only 4.6. But if it had been 4.750, and if I have to round it off to 1 decimal place, it's going to be 4.8. Okay. So let's go through this case by case again. So this was just few examples. This is how you round it off. So this rule say that to round off any number greater than 5, if the next digit is greater than 5, then you are going to add 1 to the number where you have to round it off to the significant figure where you have to round it off to. Okay. So for an example, there is something like 4.567, and if I have to round it off to 2 decimal places, I know 7 is greater than 5. In this case, I would directly round it off as 4.57. Let's say, like the next rule says that less than 5, it should be 0 only. You should not increase the number. So for an example, I have something like 4.63. In that case, if I round it off, it would be only 4.56. Okay, and now the next thing says that 5 trailing any non-zero number is +1. So if I have to round off any number and there is 5 next to it, okay, let's say we have something like 4.751. Since this 5 is followed by 1, why only last digit? I didn't get it. Last digit is only your concern, right? Last digit is only your concern. So let's say, so one of the students asked a good question. Why are you only considering the last digit? Why not if this is followed by 4.51 63? Why are you not considering all those numbers? So the thing is, let's say I have to measure something and maybe communicate it to you, and what I measure is something like 1.785 meters. Okay. Now, if I have to tell you that it is 1.785 meters, and if I measured it until the next digit, okay, and I found out it is 1.7851 meters, then probably I know it is not near 7.8, but rather it is near 7.9 meters. Think about that scale you have. Where are you going to round it off to? You are going to round it off to number nearest it is to. Rounding off means you are expressing the value as much accurately as possible to the extent to the nearest scale value. Okay. So if on a scale, if I have measured it until 1.751 meters, and if I'm going to tell you it is near 1.8 meters, that is correct. But if I told you it is more than 1.8 meters near to 1.7 meters, that is not correct, right? That is wrong way of expressing things. So yes, that is why you are only concerned about the next very digit. Okay, that tells you the distance between where it should lie. Okay, so let's come to the rule number 4. Rule number 4 states that if you have 5 and it is 0 next to it. So for an example, 4.75 then when you are going to round it off, since it's an odd digit, you like to keep everything as even, you're going to say it is 4.8. Okay, if it was 4.6 650, you're going to say it as 4 point. In this case, there is no logic, guys. Okay, in this case, there is actually no logic. But this you have to remember. You like to always keep the things as even. Okay, if you are noticing it, after when 5 is following the things, you're always trying to keep it as even. Okay, this is only when 5 is trailed by 0. Then you're noticing the number where you have to round it off. Okay, let's move forward and understand more of it. Like that would give us more examples. Like so I'm going to say I have to round it off this given thing over here to 4 significant figures. 4 significant figures. Which are those 4 significant figures? It ends over here, right? At 7, 4 significant figures, and 1, 2, 3, and 4. Okay, if I'm going to round it off to 4 significant figures, what is the number trailing it? That is 4. So what should it be? 500.07. Okay, this thing should be 500.7 only, because it is trailed by 4, which is it greater than 5 or less than 5? Less than 5. Okay. Now similarly, let's get into the next part of it. So now they are asking us to round it off to 5 significant figures. Where does the fifth significant figure lie? 1, 2, 3, 4, 5. Okay. Now the next is 5. Now when it is 5, you are going to notice the numbers next to it. The numbers next to it are greater than 0. Okay, these 3 numbers are greater than 0. Okay, so how would you round it off to? 4.75, sorry, 5.0075, sorry, 500.75. That is how you would express it. This is more accurate, right? Rather than saying 500.74, this is more accurate. 500.75 is nearer to this number. So rounding off means you're rounding off to the nearest numbers. Okay, that's actually a very good question, Pushpalata. Really, really good question. So this tells you this is rather near 500.75 rather than 74. Measure it, think about a scale, and you will get the answer. Now let's round it off to 6 significant figures. Okay. So which is the 6 significant figure? 1, 2, 3, 4, 5, and this is the 6. It is followed by 5. And the next numbers to it are 0 probably. There is nothing. So probably 0. Now what would you do? You would analyze this number whether it is even or odd. Your question is whether this number, the 6th significant figure, is even or odd. You like to keep things as even. Okay, we are more used to even. So this would be rounded off as 500 dot or decimal 7, 4, 6. Are we correct? Yes. This goes by rule. Okay, we really don't know whether it is nearer to 500.746 or 500.745. But as a rule of thumb, since this is odd, we are going to make it as even. Okay. So now in this case, let us round off this to 5 significant figures. Okay, 5 significant figures. 1, 2, 3. 7 is the 4th one, and this is the 5th one. How do you round it off? Since it is followed by 5 and 5 followed by nothing, this is followed by nothing, This is 4 over here. This is even or odd? This is even. You like to just keep it as even. So if you round it off to 5 significant figures, only 500, 500.741. Okay. I think we have gone through all the cases. Now there is rounding off in addition and subtraction. So the rule is really simple, guys. Like what I told you, how does rounding off helps us is like one of the ways is to express the nearest accuracy that we know, and the other thing is also while we do mathematical operations. So when we are doing mathematical operations, we should make sure we do the mathematical operations as usual, but we are only confident about the least precise value, not about the most precise value. So your measurement actually cannot be more accurate than your least precise value. Okay, let's for an example take the first example. So this is about addition and subtraction. Addition and subtraction, the rule is simple. You would only count up to the least decimal place. We will use the least decimal place rule. We'll understand it with an example. So let's say we have like 1.001 meters and you want to add it to 2.02 meters. You're only confident about 2.02 meters, not about 1.001 meters, because here you haven't expressed until that third decimal point. Okay, whenever I'm going to write it down, like, let's say I'm really adding two cloths, one cloth is of 1.001 meter and the other cloth is of 2.0 meter, or any, like for any two objects that you take and you add them. Now, like which one you are more confident about? You're confident that I expressed this until the two decimal points. Once you're going to add it, you don't know what is the value. You'll keep it to this, only this decimal point. Okay, so this would be written as 1.0. Actually, if you add it, if you add it, actually, what is the value? If you add it, it's going to be something like 3.021, but you are going to round it off to that least accurate value. What is the least accurate value? 2.02. You are only confident about it may be near, 3.02, and you will follow all the rounding off rules, students. You will follow all the rounding off, students, while you are rounding off things. Okay, do remember that. Now the thing is, how about this? If I subtract 3.013 minus of 2.01, what it should be? Like, let's first calculate what it should be, and then we'll move forward and round it off. Okay, to that least accurate value. So this should be 1.003, but we are only confident until 0.01, and this is anyway number less than 5, I guess. What it is, right? 1.003. Okay, so I will just call this as 1.0, not just 1 but 1.00 with accuracy. Okay, how about this 5 plus 2.01? It should be only 7. If you are actually going to get something like 7.01, but we don't know whether this 5 was measured until the second decimal, so we cannot confidently state this. So we will only say that 7 is the correct answer. I hope everyone understood this, how to express it. So this is about rounding off in addition and subtraction. You can find more problems on this, maybe we'll bring it up in DPPs, but now we are just going to explore the concept for rounding off in multiplication and division. So when I'm talking about multiplication and division, I'm not worried about this. It does not follow decimal place rule, but rather it follows least significant figure. So what this says is, if you have two quantities and if you are multiplying them, in that case you can only be sure about the least precise measurement again, but in this case you are only counting the significant figures. Okay, only worried about the significant figures. Not the decimal places, but the significant figures. This is the rule, guys. Okay, this may sound very counterintuitive. The entire significant figures concept is very counterintuitive to what we have been learning until now. But think about it in terms of measurements. Then it will sound little intuitive, at least as far as the addition and the rest of them subtraction is concerned. Okay, so let's say in this case, I'm multiplying two quantities, one is 1.1 and the other one is 2.0. What should be the expression? Should be 2.2. But instead of this, okay, let's say I'm multiplying 1.1 with just 2. Then in that case, I don't know whether it is 2.2. Maybe it is only 2. Okay, maybe it is only 2. But let's say if I had multiplied it by, instead of 1.1, I multiplied it by, instead of 2, I multiplied it with, let's say 7 or 8. More, this would give us, better understanding. Maybe it is near 9. We're going to get 8.8, but you have to round it off, right? To only one significant figure, that's going to be 9. This should be the answer. Whereas in this case, we got the answer because both had two significant figures and you had to round it off to two significant figures. Okay. Now, how about this division over here? So you first of all do as usual, like how you divide things. 3.3 by 3, you know it is going to be 1.1. But while you are going to express it, you are going to say this is not the most accurate way of expressing it. Because your 3 could have been something else. And now you would say that the expression should be just 1. Because 3 has only one significant thing. Right? 1.1 into 3, what should be the answer? Just answer would be like 3.3, value would be 3.3, but you would round it off to one significant figure. It's going to be just 3. Okay. So that is about rounding off and multiplication and division and also addition and subtraction and about significant figures and dimensional analysis of some quantities that we had, some important quantities that we need to know. And students, do share this video because this is very important, and also go through this lecture again and again. And this should be, significant figures you should only go through once. And how would you get the questions in significant figures? You're not basically like how you saw in the examples. The examples was to make you realize like this is how you do it. But maybe, you're given your answer, same answers are given in 2 or 3 options, but there's only one correct answer question. There, you are going to make your decision using significant figures. There, you are going to round off values using those rules that we discussed today. Okay, rounding off on significant figures will not be explicitly asked in your exam. Okay, it would be kept hidden in the options, guys. There would be 2 or 3 options that would be correct, but only, the value would match, but the correct answer should be the one with the given rules. For an addition, the significant figures should be the decimal places should be the same as the decimal places with the least accuracy. And similarly, in multiplication, the number of significant should be the one with the least significant figures. So these kind of things can happen in your exam, and maybe they'll give you a hint. But remember, it would not vary a lot, it should only vary a little. And do remember, how many significant figures do any universal physical constants have? Infinite. Pi as infinite significant figures. Root of, not a proper root has infinite significant figures. Cubic root of not a proper cubic root has infinite significant figures. And if you divide a number, let's say if you are going to divide, let's say 10 by 9, you have infinite significant figures. Okay, infinite significant figures is a concept that is somewhat new to you. You should learn that. I'm not sure when JEE syllabus means, okay, so one of the students has asked how JEE syllabus would reduce. I'm not sure when I mean, like, it will not reduce probably just like how it happened in your, NCRT syllabus or CBSE syllabus, because the thing is, there are many important topics. Those are those topics from which you frequently get your questions in your exams. They may not completely eliminate those topics, and it was also very important for your fundamental understanding of your, physics. That way, I don't think they will eliminate it the same way. Maybe some chapters may be eliminated. Maybe, for an example, color coding of resistors, it can go out of syllabus after 1 or 2 years. It's totally possible. And maybe some topics that are not very much necessary for your learning, or maybe that will come up in your advanced classes. Maybe that would have been eliminated. But NTA must exclusively announce that your syllabus has been reduced. Until then, don't assume it, guys. Until then, don't assume it that your syllabus is reduced. And students, do share the channel, do like the video, and make sure you get the information to everyone. And also this information that don't assume based on your previous syllabus, your syllabus is reduced. NTA should announce that syllabus is reduced. Okay, or for IIT JEE Advanced, like any of the IIT authorities should announce that your syllabus has been reduced. Until then, don't assume that syllabus is reduced. If you are so afraid about things covered, those topics that will be sure shot in your exams, or that have been asked so many times in your previous year exam. But 2021 aspirants, you have no choice. You have to move assuming that none of the syllabus has been reduced. And 2022 aspirants, maybe you can take some shortcuts, but why do you want to do that right now? You miss out some important concepts that is required for your learning. So students, do share the channel, do like the video, and keep smiling. Ignore gossips. You need to work hard and smart to achieve your success, and keep acquiring knowledge and share it, guys. Share it. It's very important that you share it. So don't worry about it so you are from state board, so you don't have to worry about things. I guess you have to only worry about your JEE preparation. I guess that is the things over there. And that being said, students, you can find our Telegram channel link in the description box below. You need to first of all download the Telegram app and then click onto this link, or you can just search JEE_English and you will be able to find us. And students, if you have missed the color coding of resistors class, especially 2021 and 2021 aspirants, please attend this class, because it's a very easy one. And there were around 5 questions in your 2019 altogether, 5 questions in your 2019 JEE Mains paper. So do not forget to attend this awesome lecture. It's a very short one. You can cover it within an hour, and we have also discussed all the necessary model problems around this in this single class. And that being said, students, to attend many such free special classes, you need to download your Unacademy learning app. All you need to do is search Unacademy on your Google Play Store and App Store, and the first option would be your Unacademy learning app, and you will click on that link and you will click on the install. And not only that, students, if you already have Plus, it would be very useful to get live notifications. Even if not, if you're attending regularly these special classes, you'll get live notifications. So do not forget to download your Unacademy learning app, students. And that being said, if you're preparing for IIT JEE, we have an awesome complete package for your JEE preparation, which comes with live test series, live quizzes, leaderboards, and dashboards that can help you improve your examination preparation. Of course, you do get a lot of your lectures on your Unacademy channels for free of cost, but there is like a technology involved in your JEE preparation, and that you can get it through a very economically paid, like a very reasonably paid subscription. And it's an economical subscription, guys. All you need to do is click on the extension bar, click on this first icon, and then choose IIT JEE as your goal, and you would have to click on the get subscription. And that being said, students, hurry up, get it as soon as possible, because the prices are going to be hiked from 10th of September. So before this hike happens, make sure you get your subscription in time, especially 11th class students. Get your subscription early. You need to hurry up, students, get it today. And that being said, how much it is going to be hiked? So right now, if you apply Murli Live coupon, you would get a subscription price for 2 years of 32,400 only. But after 10th of September, it is going to be near about, I mean, like it's going to be 550,400 even after you apply Murli live coupon, which is after that best discount that you can. So that being said, do not wait anymore, especially if you are planning for your IIT JEE preparation. We have the best in class faculties and best in class authors and best in class educators on this platform. On the single platform, it is one subscription and unlimited access. Right now, the prices are low. It's anywhere around 1,500 for your 24-month subscription. And like your 24-month subscription, it's only going to cost you 1,500, near about 1,500 per month. If you apply Murli live coupon, even on this, you will get a 10% additional discount, guys. So that's very economical. Right now, it's very economical, students. So avail it as soon as possible. And long-term and dropout students, you can also get it, as soon as possible, so that you are getting ready for your JEE preparation. You don't have to worry about anything. We have all the best in class facilities, be it technology or be it educators or be it the kind of the knowledge, like the knowledge banks that we have. So do not hesitate, or do not you don't have to have a second thought to get an academy subscription, because it is the nation's leading and the largest test preparation platform that is impacting about 10 million lives a day. So you can be one among them, and you can learn in a very systematic manner on this Unacademy subscription platform. Do not forget to apply the Murli Live coupon. Take care, stay safe, bye bye, see you in the next class, students.